Okay, so this first question on circular motion, we are looking at centripetal forces on the Moon as it orbits the Earth, and at a center-to-center distance of 3.84 by 10 to the 8 meters. It's got a period of essentially the month, so 27.4 days, and we're given the mass of the Moon. So this force is, of course, a gravitational force, and it's the force that causes the Moon to travel in uniform circular motion, so it needs that force towards the center of its motion, or towards the Earth. So if we're thinking about the F net on the Moon will be equal to its F centripetal, and in this case will be equal to mass times A centripetal. And that's what we're trying to basically figure out, is this centripetal force. It is the net force on the Moon, and that's what we're going to consider it as, the net force on the Moon. We're not going to consider any other gravitational forces on the Moon, just the one by the Earth. And we're going to try to figure out what is the value of this FCP. So we need the mass and we need the centripetal acceleration. So there are a number of equations which define ACP, but ideally we want the one with preferably a period. So FCP will be the mass. This is v squared over r, but I would recommend considering the expression of 2 pi over t ought to be squared times r. So v squared over r, v can be described as 2 pi r, so the distance divided by the period. Once you square that r, you'll end up with an r squared on top, divided by an r, so you're just left with 1 r on the top. So this is, in a sense, the acceleration in terms of the period, or you can describe it as 2 pi f if you're trying to describe it in terms of the frequency. But period is the most convenient, because that's what we're given here. We're given the mass of the Moon, and you're given the radius. So here, the only challenge here is to determine the period in terms of seconds. So days is not the correct SI unit for time. So the mass of the Moon, we would have 7.35 by 10 to the 22 kgs. Try to fit all of this here in one line. So we have 2 pi, probably going to run out of room here. So you have 27.4 days. You want to multiply that by 24 hours in a day, and you want to multiply that by 3600 seconds in an hour. So that full conversion, so 27.4 days, 24 hours in a day, 3600 seconds in an hour. And then you want to multiply that, of course, by the radius. So again, I'm not sure if I'll fit it in here. 3.84 by 10 to the 8 meters, so it's a bit messy. So once you multiply these quantities, the mass of the Moon again, this whole thing in parentheses, oh, missing my square here. So the 2 pi over all of this, this fraction, all to be squared, then times the radius, should leave you with a centripetal force of almost 2 by 10 to the 20. So 1.99 by 10 to the 20 newtons. That should give you a choice C as the correct answer.